We're about ready to start the exercise 1 on this handout here. And just before we jump into the exercise, I wanted to say something about notation because I know this can be confusing for people, some alternate ways of writing things. So in our first example, we had f of x equals x squared and g of x equals x squared plus 2. Now, we could kind of put this information together. Because f of x is equal to x squared, I could have substituted it in here and written g of x equals f of x plus 2. Sometimes you see the function relationship described in that way for these two functions. And also, you can always call the output for a function y. So sometimes we'll write just y there. We don't want to write y in both positions because that just means two different things. But here, because g of x is the output for this function on the right, sometimes we'll write this y equals f of x plus 2. So in this context, these all mean the same thing. In our second example, where f of x was the absolute value of x, you could have done the same thing. You could have said g of x is that f of x minus 4, or y equals f of x minus 4 for that function, because we're going to see some of this y notation now. In the third example now, it's a little bit different. We can still bring in the function f, but we can't just substitute in f of x. We got to realize that this is like a composition. So this is actually f of x minus 3. No squaring, just writing f of x minus 3. Think of what that composition would be. F of x minus 3 would be x minus 3 in parentheses squared. And then, again, sometimes books will just say y equals f of x minus 3 and not even give the new function a name. This represents the function g, but we're not using the g name for it. And one more example of this notation in our last one. So the fourth example is sort of similar to the third. F is related over here to g on the side. We can't just write down f of x because we got a composition again. This is f evaluated at x plus 2. So we can think of that as a composition. So compare these last two examples. And again, sometimes people will just write y for g of x and just write f of x plus 2 in parentheses to describe the new function. So the new function, the three on the right are the same for each one of these situations. The three on the right mean exactly the same thing. Unfortunately, we have too many ways of saying exactly the same thing. Okay, so let's go to the homework or the exercise, sorry, not the homework, but the exercise. And let's see, here it is. What I did was, what I'm asking you to do is start with this graph that's given on the handout and transform it in each of the following ways. So you're going to draw 5 separate graphs, all based where this is the original f of x. We don't have a formula for it. All we have is the graph, and we're going to try to make those transformations. Now, to make this a little bit easier for us, I posted in Canvas a handout that is really just this exercise. So this is transformations of functions, worksheet for exercise 1 from the class handout. The graph of a function f is given on the same grid. Sketch the transform function, because this makes the whole process a little bit easier. It's exactly the same exercise as this exercise from the handout. What I did was I copied this y equals f of x function over and over again. So the graph of a function f is given. In each case, this is the original f, the original f, the original f. Just same picture over and over again. And then what we're going to do is we're going to transform f to get a new function as being requested in part A, B, C, D, E in each case. Okay, so I just want to make sure those instructions are clear. And having a graph grid, I made sure the grid showed up because it just makes it a lot easier to do the vertical or horizontal shift if you have actual squares on a piece of paper to work from. So I'm going to do the transformation in red. So for each part, like this part A, I'm going to draw the new function in red, the y equals f of x plus 1. So I'm adding 1 outside the expression of a function. That's the vertical shift situation, right? I have to shift upward 1 unit. So I just take points on the graph I know and shift up 1. This one will go up 1. This point down here, go up 1. This 0, 0 point will shift up 1. This point up 1. And I'd get a new graph in this position. Sorry, that's the point there. So that's the new graph. We shift up 1 unit to get f of x plus 1. Okay. Now let's do part B. Here the plus 1 is inside the parentheses of the function. So this is a horizontal shift situation. And so to graph this, we need to shift sideways horizontally. And unfortunately, or well, we just got to get used to it, when you see a plus 1 inside parentheses, we don't shift to the right, we shift to the left. We have to go left that away 1 unit. So this point's going to shift to the left, this point 1 unit to the left, this point 1 unit to the left. Maybe I should just draw a little part of this now that I got it that much. This point will shift 1 unit to there. This point will shift 1 unit to there. And there's, again, there's the graph that's being asked for. Okay. All right, now, so it's a little bit of an exercise in interpreting this abstract function notation. Part C. Part C is actually similar to part A, right? Because we're subtracting for outside the function expression for f of x. So we got to go down 4. And so this point goes 1, 2, 3, 4. It looks like I gave myself lots of room here, right? This point goes 1, 2, 3, 4 down. The origin point goes 1, 2, 3, 4 to here, and I like drawing a little bit of it to get before I add more points. From here, 1, 2, 3, 4 down. And from here, 1, 2, 3, 4 down. So the new function, I didn't give it a function name, I'm just expressing what that equation is down there. Okay. Okay. Now, another one, part D. We're back to working inside the expression of the function. So we're doing a horizontal shift. And it's minus, so we actually have to go in the positive direction, or we have to go right, which means that away 4 units. And maybe I'll start at this end so I don't overlap myself here. At this end, 1, 2, 3, 4 moves over to here. 1, 2, 3, 4 moves over to here. The origin 1, 2, 3, 4 moves over to here. So that piece is going to be shifted over to this position. This lower point, 1, 2, 3, 4, gets shifted to there. And finally, this point, 1, 2, 3, 4, lands here, but notice it's looking something like that. Okay? So the graph of this new function, this transform function, is the red. Right? And then finally, part E, what we're doing is we're combining two different transformations. And we're going to learn how to combine them as we learn more and more about transformations. So here we got two things going on, right? We have to, outside we have plus 2, so we have to shift up 2. But then inside we have the minus 2, so we also have to shift to the right 2 that way. And so you're just going to go up and to the right with each point. So for instance, this point here, we want to go up 2 to the right 2. This point here is going to go up 2 to the right 2. The origin point is going to go up 2 to the right 2 to there. So that first sort of peak is going to be in that position. This point, I'm going to go up 2 to the right 2. So we're coming down to there. This point at this end, I'm going to go up 2 to the right 2. So it can, when you have several transformations, it can get a little bit tricky when you guessing what happened when you see the final picture, because the transformations are all mixed up. And so there's our function for that one, and that's part E. So there's the 5 parts of exercise 1, A, B, C pictured, and D, E. And now we're going to move on to some other kinds of transformations.